Hello, this is Mr. Collier, and today we're doing optimization with quadratics. Okay, so in this first example, stone is projected upwards from the ground. The height above the ground is given by this formula right here. Okay, this is like a quadratic. This is very similar to y equals 20. Very similar to y equals 20x minus 5x squared. Instead of x, we have t for time and h for height. So it is a quadratic. It's a downward facing quadratic because the a value is negative. And when we have a downward facing parabola, then we have a maximum value. In this case, that's going to represent the greatest height achieved, or the maximum height. Okay, so actually I'm probably going to answer part B before part A. Kind of makes more logical sense. Find the greatest height. So basically we're going to be finding the vertex of the equation. Okay, so we have this. We can actually figure out the x value of the vertex by doing x equals, or even t in this case, t equals negative b over 2a. And the b value is 20, so it's negative 20 over 2 times the a value, which is negative 5. Okay, so that equals 2. So after 2 seconds, we reach this maximum height. Okay, to get the y value, we simply substitute, or the h value, we simply substitute 2 into this equation. So we have 20 times 2 minus 5 times 2 squared is 40 minus 20, which equals 20. So the maximum height reached is 20 meters. So for part B, it's 20 meters. The range of h means the range of the heights. Now notice though that of course your height can't be negative here because we're starting from the ground. So the height goes from 0 up to 20. So we say the range is h is greater than or equal to 0. Less than or equal to 20. Okay, in the next example, a piece of wire of length 60 is bent to make a rectangle. Find the maximum area of the rectangle. Okay, so let's draw the rectangle. The perimeter has to be 60, so if I call one side x, and the other one is not 60, but 30 minus x, because the two sides here have to add up to 30, or half the perimeter. So this is what the rectangle looks like. So the area is x times 30 minus x, which is a quadratic. It equals 30 minus 30x minus x squared. Okay, so that's the formula for the area. We want to find the maximum area. So again, this is a downward facing parabola. The maximum area is just the vertex of the parabola. Okay, so again we can get that by negative b over 2a, which equals negative 30 over 2 times negative 1, which equals 15. Okay, so if x is 15, we have the maximum area. Actually, that makes sense because the maximum area in this case is going to be when it's a square. So it's a 15 by 15 rectangle. So the maximum area simply equals 15 times 15, which is 225 square centimeters. Okay, next we have a man wishes to make a rectangular enclosure using existing fence as one side. So he's already got a fence. He's got 20 meters of new fencing. So his new fence is going to look like this. So it needs 3 sides. Okay, this kind of example is not going to end up being a square. He's got 20 meters, so if I call this x and x, then this is 20 minus 2x. Okay, because they all have to add up to 20. So the area is x times 20 minus 2x, which is 20x minus 2x squared. Okay, so this is again a downward facing parabola, so the maximum is right there. So we need to find the x value, the maximum. It's x equals negative b over 2a, so it's negative 20 over 2 times the a value, which is 5. Okay, so that's 5. And to get the maximum area, we simply substitute 5 into the equation. I'm going to substitute to this version. 5 times 20 minus 2 times 5, which is 5 times 10, which is 50. That's the maximum area that the farmer can make.